Welcome to IOQM 2024. Let's solve the problem. This is the last video, part 4 of the video. Okay. In this video, we will solve the last 5 problems, 5 marks questions. Most of them will be definitely, you can expect them to be tough. 26 to 30, this 26, 27, 28, 29, 30. Okay. These are the 5 problems which we will solve in this video. Okay. Let's go. Okay. 26th problem. The sum of floor of x for all real numbers x satisfying the equation 16 plus 15x plus 15x square equal to floor of x cube. Okay, is here. This is floor of x value, which means if you take 5.1, floor of x, floor of 5.1 is 5. Floor of 5.9 also 5. Okay, you will take the floor value, integral value. Okay, so we need to find the sum of all possible floor x values. Okay, for all real numbers satisfying the x. Okay, this equation. Okay, so yeah, let's do this. This is the given equation, and we know that the floor of x value always lies between one number before, okay, and one number of, I mean the same number basically, right? So which means floor of x is always greater than x minus 1 and less than or equal to x. Okay, once you know this, you can derive some equation from this, correct? One inequality we can derive. Now floor of x is less than or equal to x, right? So x is greater than. So if I replace here x cube is always greater than, correct? X cube is greater than or equal to 15x square plus 15x plus 16. Now we have an inequality here. Now take the inequality into cubic terms. Okay, this is the one. Okay, you can actually factorize it. So we get is x minus 16 into x square plus x plus 1 is greater than or equal to 0. Okay, here x square plus x plus 1 is always positive. You can calculate that. Okay, it's very easy to prove. Take less than 1 value, you will definitely have, even if you take negative value, it will become positive by this plus 1. Okay, when it is more than 1, x square is always dominates, so you will have a positive value always. Okay, so since this is positive, this is always positive, this also should be positive. Okay, which means x should be greater than or equal to 16. This is our first uh, hint, right? This is our first hint. X is greater than or equal to 16. Now let's check what are the values possible. Okay, and where the equation goes out of range, and that you can stop checking for the more values, right? So at x equal to 16, this expression, both sides are equal actually. X cube is equal to 15x square plus 15x plus 16. Okay, this is satisfied. Okay, x cube and 15x square plus 15x plus 16 both are equal. So x equal to 16 is a solution by itself. Okay, now next. At x equal to 17, it's not equation but inequality is satisfied. Okay, it is x cube is greater than 15x square plus 15x plus 16. Okay, the equation is satisfied. Okay, because you can take the values. Okay, this is x minus 1 cube value. Okay, x minus 1 cube value here. Okay, at x equal to 18, this is also it satisfies. X cube is greater than 15x greater than or equal to 15x square plus 15x plus 16 greater than x minus 1 whole cube. You see the range of values here. Okay, this is x cube. This is the 15x square plus 15x plus 16. This is x minus 1 whole cube, which is from here we get it, right? At x equal to 19, this equation is not satisfied. Inequality is not satisfied. Okay, you get values like this. So which is not right. Here it will fail. So this is not satisfied. Now as you go above, as you go more, x cube always dominates, right? Cube value will increase much more than this value. So this will fail always. Okay, this inequality won't satisfy, right? So we will stop here. Now let us understand from this expression what are the possible values. Okay, one is x equal to 16 is the exact match, so this is a solution. Second one is x is between 17 and 18. Okay, 17 and 18, right? Okay, now this means what is the meaning of it? We are looking for a floor of x value, right? So floor of 16 is 16, and floor of 17, between a value between 17 and 18 is always you get 17, correct? Floor of any number between 17 and 18, you get only 17. So these two are the solutions. 16 and 17 are the solutions. The question here asked is sum of, okay, sum of floor x values. So the answer is 16 plus 17, which is 33. This is the answer. Okay. So this problem is hard only from the point of view that you need to do a lot of analysis, and you might go wrong here thinking that x equal to 18 also a solution. Okay. That's not right. Here we are trying to tell x is between 17 and 18. That's what we proved. X equal to 17 is not satisfied. X equal to 18 is not satisfied to the exact equality, right? So it is between 17 and 18. So floor value is 17 of that one. Okay. So it's again number theory problem. I am always telling you should be very, very good in number theory. It will help a lot in any of the maths field. Okay. You should be very good in number theory. Okay. Let's see next. Problem 27. This is one very beautiful geometry problem. I think whether you solve it in Olympiad or not, you should solve this problem after that. A very, very interesting problem. Okay. In a triangle ABC, a point P in the interior of ABC. Okay. Let's see that. This is the triangle ABC. P is any point in the interior. Okay. P is any point in the interior. First, we'll understand the problem. Then it's very easy to solve it. Okay. Such that angle BPC minus angle BAC. Okay. This is they gave in symmetry. So I'll just explain here. Angle BPC is this one. Okay. Angle BAC is nothing but angle A. Okay. So if this is, you call it x minus A equal to y minus b equal to z minus c. Okay. This is what is given information. And also other information given is BAC is 30 degrees. AP is 12 centimeters. Okay. Then let DEF are 3 points. Okay. And perpendiculars drawn from this one P, D, E, F. Okay. And you form a triangle with DEF. Okay. What is the area of the triangle? Okay. In different terms, we have to solve that. Okay. We have to find the area of the triangle and it will be in the form of m root n. Then what is the product of m into n? Okay. So first thing you need to find out is first target is area of DEF, okay, triangle. Now, how to form this? Before forming DEF, let's derive some simple values from this one, okay, from this given information. This is the given information. These angles are same. This angle x minus b, y minus a, z minus c, right, equal to k. Let's take. Now, if I sum all three equations, because this is equal to k, this is equal to k, this is equal to k. I summed up all of them. So, okay, what I will get is angle BPC minus angle BAC minus angle CPA. So, what I'm getting is sum of all these three angles minus sum of these three angles equal to 3k. Okay, this is 360 degrees. This is 180 degrees, three of them. So, 360 minus 180 equal to 3k. So, k is 60. Now, once you know this, okay, once you know this, it's very easy. BPC minus BAC equal to 60, correct? Because it is equal to K. BAC is given as 30 degrees. Okay, BAC is given as 30 degrees. So BPC is 90 degrees. So this is a 90 degrees. Okay, this is one information which we got from this information, right? CPA is nothing but CBA plus 60. Then APB also 60 plus ACB. Okay, so this is the other information. Now we'll go to next step, drawing the DEF and then solving the problem. Okay. Remember this is 90 degrees. Remember this is 90 degrees and this angle is 60 degrees plus B. Okay. B plus 60 is this angle. Okay. This is A plus 60. This is 30. This is 90. Okay. This is C plus 60. Remember that. Then we'll go to next slide. Okay. So this is the triangle. Ignore the arrow here. Now DEF are 3 points, okay, on BC, AC and AB. These are the perpendiculars drawn from P onto these three lines. So these are perpendiculars. The red lines are perpendiculars. Okay. Once you know this is perpendicular. Okay, this is the triangle which will form. We need to find area of this DEF. Okay, now let's check all the angles properly. Okay, let's call this as X angle. Then this is also X angle. How? Okay, think. Okay, FPDB. FPDB is a quadrilateral. This is cyclical quadrilateral. Why I am telling it is cyclical quadrilateral? Okay, it is cyclical because if I draw a circle here passing through all these, okay, this is the BP is the diameter because it is forming 90 degrees on the circle, right? Semicircle, 90 degrees in the semicircle at F and at D, okay? Which means if there is a circle drawn on this quadrilateral, okay, BP is the diameter, right? So this is a cyclical quadrilateral. Cyclical quadrilateral property is, okay, this one, x equal to x. Okay, this angle is equal to this angle. You should know this. Okay. Now with this we can solve all the angles in this. All the angles we can find out. Okay. Let's see how. Now this is x. This is b. This is y. So this also will be y. Same cyclical quadrilateral property we can apply. Angle property. Okay. So this is also y. Now you know the what are the things you know? This is x, this is y, this is 90. So in this triangle BPC, this should be, how much this should be? 90 minus y, correct? So this is 90 minus y. If this is 90 minus y, okay, this is also 90 minus y, okay, because this is also cyclical quadrilateral here. This is 90 degrees. So this is also cyclical quadrilateral. So these angles are equal. Okay. Once you know these angles are equal, now how do you get this angle? Okay, how do you get? Yeah, this angle. This angle is nothing but x plus y. This is x plus y plus 60. X plus y plus 60. Oh, sorry. This is 30 degrees. Correct. This is 30 degrees. This is x plus y. This is 90 minus y. Okay, so remaining is 60 minus x. Okay, 180 degrees, right? These three angles are 180 degrees. So remaining here is 60 minus x. Once you know this is 60 minus x. This is also 60 minus x. This angle PDE also 60 minus x. Cyclical quadrilateral property I just explained. Now you know this one. Next, go to the next step now. This will be 60 minus y because this is x plus y plus 60. X plus y plus 60. This is 60 minus x. So this has to be 60 minus y then because APB is a rectangle. Correct? Once this is 60 minus y, this is y minus 30 because this is 30 degrees. Right? Now come back. This will be, if this is 60 minus y, this is 60 minus y. This is y minus 30. Right? Now you check the angles here. Okay? Angle at F in DEF triangle, angle at F is 60 minus y plus y, which is 60 degrees. Okay? And angle at D is x plus 60 minus x, which is 60 degrees. Okay? Angle at E is y minus 30 plus 90 minus y, which is 60 degrees, which means DEF is a equilateral triangle, right? This is a equilateral triangle. Now, things are very simple. Now you know that equilateral triangle, what do you need? You need only one side to calculate the area, right? So EFD is the equilateral triangle. Given that AP is equal to 12 and BAC is 30 degrees. Here it is 30 degrees. This AP is 12. Okay. Now, look at this. AFPE is a cyclical quadrilateral with AP as diameter. I explained why it is here because here it forms a 90 degrees on the semicircle, right? This is a diameter, which means AP is equal to 2R diameter, right? 2R equal to 12. AP is 2R, which is equal to 12. Now, the same circle which is circumscribing this quadrilateral also circumscribing, okay, also circumcircle for the AFE, AFE triangle, correct? AFE triangle. Now, if this is circle of AFE, then 2R is equal to 12, correct? What is the radius of that circle? 6 centimeters, because 2r is 12. So 2r equal to, yeah, 12 for that circle. Now in this triangle AFE, you apply the sine rule. Sine rule, how you are apply? EF by sine 30. EF by opposite angle is sine 30 is equal to 2r, right? Which means EF is equal to 6. Now you got EF. One side of the equilateral triangle you got, which is 6. Which means area of the equilateral triangle is root 3 by 4 into EF square, right? Which is 9 root 3. This is in the form of m root n, right? So m is 9, n is 3. So m into n is 27. This is the answer. It looks very tough actually, but only very simple principle you should remember. The angles here are equal in a circular quadrilateral, right? Once you know this is very easy problem. But I don't say a problem is easy. Yeah, you need to do without mistake. You have to go from one angle to rest all angles you have to calculate without any mistake anywhere, right? So definitely it is a tough problem, but very, very interesting problem. Everybody should solve this. Okay, yeah, this is hard, definitely. Next, 28th problem. Find the largest positive integer n less than 30, positive integer n less than 30, which means n is between 0 and 30, right? Such that half of n to the power of 8 plus 3 n to the power of 4 minus 4 is not divisible by the square of any prime number. Okay, we should find n in such a way, okay, largest n in such a way that this expression, if you call this f of x, this f of x should not be divisible by any square of prime. Okay, any square of prime. Okay, so maximum value you will take is how many primes you will count. Basically, if you substitute 29 n equal to 29, whatever is this f of x comes, okay, the prime less than that is what you will count. You don't need to go above. Okay, but do you need to really check that big number? Okay, we need to only reduce the possibilities of checking numbers. Okay, you can take in 29 values of n, it will satisfy somewhere. Okay, you go down. Basically it is said you need to find largest positive integer. You go 29, 28, it will hit somewhere. But looking at this expression, we can simplify it. Okay, so that's what let's see how easily we can simplify and how many values we should basically substitute and see, get there. So f of x is this expression. So this is nothing but half of n to the power of 4 plus 4, if I factorize, into n to the power of 4 minus 1. And n is between 0 and 30. This is important. N is between 0 and 30. Okay. No, it's a positive integer. Okay. No. First case one I will take all odd numbers. So from 1 to 29, I am taking all odd numbers. Okay. Now n is odd and n is greater than 1, because for n equal to 1, f of x is 0 anyway. So any number will divide it, right? So ignore that directly. F of 1 you can substitute and see, it will come 0. So 1 you forget, n is odd and starts from greater than 1, which is, so 3 to 29 is what I am checking. Okay, how I am checking? F of x is nothing but half of n to the power of 4 plus 4 into n square minus 1 into n square plus 1. Now you know this from number theory if you are good at. Okay, n square minus 1 is always is for a odd n. Basically if n is odd, n square minus 1 is always divisible by 4. Okay, you check, actually it is divisible by 8. Okay, but we are not interested in 8, we are interested in square of a prime, which is 2 to the 2 square, which is 4. Okay, so if you substitute values, let's say 3 square is 9, 9 minus 1 is 8. Okay, 5, 25 minus 1 is 24, divisible by 8. Okay, 7, 49 minus 1, 48, divisible by 8. Okay, so if something is divisible by 8, it is also divisible by 4, right? So all odd numbers you can ignore now. From the list of 2 to 29, you can ignore all the odd numbers. We ruled out. So case 2, let's go to even. Okay, n is even now. So a even number can end with 2, 4, 6, 8 and 0, right? 2, 4, 6, 8 and 0. Okay. Now looking at n square plus 1, something should strike on. Okay. Correct? Looking at this n power 4 plus 4, something should strike for you. Okay. If n is ending with 2, 4, 6, 8, n power 4 is always ends with 6. N power 4 always ends with 6. Why? You check. If you want, you can check. 2 to the power of 4 is 16. 4 to the power of 4 is 16 into 16, which is ends in 6. 36 into 36 ends in 6. 64 into 64, 4 into 4, which ends in 6. So every even number ending with 2, 4, 6, 8 ends with 6. Now this is ending with 6. Okay. This is ending with 6. Correct? Plus 4 we are doing. N square plus 4, right? So n power 4 is ending with 6 and plus 4 you are adding. So this will always end with 0. Okay. This always end with 0. So multiple of 10 here and n power 4 minus 1. Okay. N square minus 1 into n square plus 1, which is n power 4 minus 1. What will happen to n power 4 minus 1? This will end with 6 always. So n power 4 minus 1 always ends in 5. So you have 10 into 5. You have 10 into 5 ending with it, right? So which means 5 into 5 also, 25 also divides this. Not only 50, 25 also divides this number, correct? So all the even numbers ending with 2, 4, 6, 8, this expression is divisible by 25. Okay. So now you ruled out all 2, 4, 6, 8 ending, all odd are ruled out, all 2, 4, 6, 8 are ruled out. We are left with only the numbers ending with 0. And how many such numbers are there? You have only two numbers, 10 and 20, because n is less than 30, not equal. Okay. You have only two numbers. Just check one by one. Okay. For n equal to 10 and 20, first n equal to 10, what happens? This is also easy. N square minus 1 you have in the f of x. Okay, n square minus 1 is 99, right? If it is 99, it is divisible by 9. So n square, n equal to 10 also divisible by 3 square, which is prime square. So this is also ruled out. So now you can blindly tell 20 is the answer. Okay, just cross check the values. It won't take much time because it's n power 8, 20 power 8 you have to do, and next is 20 power 4. So I think you can easily do it. The number comes is this one, and this is not divisible by 2 square, 3 square, 4 square, 5 square, which you can easily check. Then you can leave it. 20 is the answer basically. This is the only number left. You have no other number left actually in 0 to 30, between 0 to 30. So n equal to 20 is the answer. Yeah, this is definitely a again hard problem. Very good number theory problem. So I always like number theory problems because they're just basic building blocks for the maths actually. Okay, do more number theory problems. You can actually solve many problems easily. As I said before, again I'm telling. Okay, this is definitely hard. Next, 29th problem. Let n equal to 2 to the power of 19 into 3 to the power of 12. Okay. Let m denote the number of positive divisors of n square, okay, which are less than n but would not divide n. Okay, what is the number formed by taking the last two digits of m? Okay, so first we need to find out capital M, which is nothing but number of positive divisors of n square. This is n. We need to find the positive divisors of n square and separate the those divisors which are less than n and don't divide n. Okay, right? This is what we should do. Now, how to do this? This is also again a number theory problem. You should be very good in number theory to understand this problem and solve it easily. This is a very easy problem to solve if you are good in number theory. Okay, so n is this one, 2 to the power of 19 into 3 to the power of 12. N square is 2 to the power of 38 into 3 to the power of 24. Right? Now, how many divisors it has? Okay, we have a formula. If you know, 19 plus 1 into 12 plus 1 you will do, right? Number of divisors of n is 19 plus 1 into 12 plus 1, which is 260. Number of divisors of n square, 38 plus 1 into 24 plus 1, which is 975. Now you know this. Okay. Now These numbers, divisors of n square, range from 1 to n and n to n square, right? And if you carefully observe, the n square divisors are equally distributed between 1 to n and n to n square. Why? N square into 1 is 1. Okay. So if you take n into n is n square again, right? If you take a number before n, one number before n, one number after n, product of them is also equal to n square. So you should have one number in 1 to n range, one number in n to n square range, okay, and product of them should be equal to n square. Then only you will get all the divisors. So they are equally distributed, 1 to n and n to n square. So very simple now. These are the divisors of n square. These are the divisors of n, and I am interested in number of divisors of n square less than n. Okay, how many are less than n? I am interested. Since this is an odd number, I am just adding plus 1 and dividing by 2. I am get 488. 488 are less than n. This is also we have come to less than n. But from this one, I should remove all divisors of n. Correct? I should remove all the divisors of n. I should remove. Correct? So what are those? If I remove all the divisors of n, 488 minus 260. Correct? Which is nothing but 228. This is my m. And what is asking? Is asking only last two digits of m. Okay? Which is 28. So this is the answer. Yeah, this looks number of steps wise, it looks easy, but it should strike to you. Okay, looking at the problem, it should strike to you that this equation is one number of finding the number of divisors. Other one is its range is symmetrical between 1 to n and n to n square, right? Then it's easy. Yeah, it's a hard problem for Olympiad students. Uh, yeah, but again, a number theory problem. So this time, so many hard problems are from number theory. Okay, so definitely hard. Okay, let's go next. Last one. 30th problem. This is the last one. Let ABC be a right angle triangle with right angle at B. Okay. Let the length of altitude BD is equal to 12. What is the minimum possible length of AC given that AC and the perimeter of ABC are integers? Okay. So what he's trying to ask is basically this is a right angle at B, right? BD is the altitude, this is also right angle, okay? And BD is equal to 12, which is given, okay? He is asking, it is given that minimum possible length of AC given that AC and perimeter of triangle ABC are integers. This B is a integer and A plus B plus C also a integer, which means A plus C also integer, right? So this problem definitely looks easy for a 5 marks question. Okay. Uh, See, B is a integer, positive integer. A plus B plus C also positive integer. I am taking it as a positive integer. Why? Because these are all lengths I am dealing with. They cannot be negative, right? So these are all positive integers. So which implies A plus C also a positive integer. A plus C also a positive integer. Now, next. Given that from this triangle I can easily see area I can calculate two ways. One is AC by 2, which is equal to 12 into B by 2, right? Which implies AC equal to 12B. This is my first equation, okay, for finding B and limits of B. Second, of course, we have a Pythagoras theorem, which is very simple, right? Now, another thing you should know is root mean square of any two numbers, okay? Root mean square of two positive numbers is greater than or equal to geometric mean. Greater than or equal to geometric mean. Actually, it will be greater than or equal to also. Okay, possible. Okay. Now, what is this mean? Okay. What is root mean square velocity? Root mean square. You will take if AC are the two numbers, A square, C square are the two numbers. Okay. I take the mean of these two numbers and square. Mean of two numbers and square it. This is greater than or equal to square root of AC. Okay. right? AC are the numbers. This is the geometric mean, square root of AC. Okay. Root mean square. A square plus C square by 2 is the mean square root of this. Okay. Now, once you know this, this is very, very easy problem. Okay. A square plus C square is nothing but B square by 2. AC is nothing but 12B. So, square roots gets cancelled both sides. Okay. From this, I can derive B is greater than or equal to 24. This is my second. Okay. Now, I know that B is greater than or equal to 24. Right. Now, I'll just simply check the range for B. What could be the possible range for B? From Pythagoras theorem, I will rewrite it as A plus C whole square minus 2AC equal to B square. Okay. AC is equal to 12B. So, it will become A plus C whole square equal to B square plus 24B, which I will rewrite it as B into 24 plus B. And we know that this is the integer here. A plus C is the integer and this is the integer whole square. Okay. Now, if I consider this as one single number, okay, then square of a number is equal to b into 24 plus b, okay, which means I should find b such a way that b is a perfect square and 24 plus b also a perfect square, right? Only then it is possible, right? Because all are integers we are dealing with, right? So, a plus b is an integer, hence b is equal to 24 cannot satisfy this, okay? I know that b is greater than or equal to 24, right? And I need to check for this rule. 24 if I take, it will become 24 into 48, so I don't get a perfect square. But at b equal to 25, I get perfect square. This is 25 into 49. 25 into 49, which is 5 into 7, perfect square. So b equal to 25 is the answer because he is asked minimum possible length. So I am going from 24 and above basically. Okay. So this is a simple problem given all the hard problems in 5 marks questions. But I would say that you should know this one rule and apply some logic here. Okay. So yeah, it's a medium problem. Answer is b equal to 25. This is the answer anyway. Okay. So this is a medium problem. Yeah, with this we ended this IOQM 24. It is relatively easier problems in 2 marks and 3 marks questions compared to last year, definitely. When it comes to 5 marks questions, I think they tested all the skills of kids. So, which is that way it is a well set paper that everybody has something to do in the paper, right? Uh, Thank you. We'll come up with more videos and more practices for Olympiad as well as other competitive exams. The basic idea is to improve math skills. Thank you.